Please put pluses if on the left side of your screen you see the slides, math refresher course, PSME, blah, 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 and on the right side you just see something from a browser that is white for now. Just do plus, plus, plus if you see that. Huh. Oh, okay. Great. Thank you very much. So, perfect. Everybody sees what you're supposed to see. Look, now there will be some exercises during my, let's call it lecture. And sometimes I'll ask you to type in the conversation part your answers and go ahead, do it. Given someone wrote different answer, it's okay. You should go with your answer anyways. So now let's begin. So you already saw that. I'm not so sure why it's August 3rd. Well, you're supposed to have a good one that I sent you. Introduction we've done. Organization I told you about. Now let's switch to course outline. And by the way, what I mentioned to you about next week presentation, there will be a bonus question that we'll do all together in classroom. So here, what do we have? We have my email, which is a preferred email of Paris 1, but given there is an emergency, you can email my weird Russian email that I read all the time. So that you should use for, I don't know, you're late for the class or something, you know, urgent. So the course outline. Today we're gonna do general reminders. What is sum? What is a product? These common operators. We're gonna refresh our knowledge of logarithms and exponents, and gonna go through some useful notations. You've seen already in the presentation that you have two last slides with different kind of notations that we're gonna use. For you it's gonna be very helpful to actually learn them because and different options of how to name one thing, like the first derivative. Some professors will use one format, other professors will use another format. Me, through the math refresher, I will also use different formats, so you get used to it. Okay, so that's for today. And maybe, just maybe, we can also start functions today. So this is some high school stuff, but with extensions. Then the topic that is the most important for you all for this semester is derivatives and differentials. The more you practice, the better it is. You know, then during the exam, you will be for sure able to take a derivative of anything and everything, and you will not waste your time on, okay, so how do I do that in math? Because, for example, micro will be super heavy in math, in derivatives, in optimization, and you really have to do this derivation automatically. So that's why we have math refresher, and that's why I have tons of different exercises and examples for you. Rules of differentiation, most likely you know them, but maybe someone forgot, maybe someone prefers forgetting right after passing exam. That happens, so you're gonna learn them again. Partial, total, because we're going to deal with multivariable functions, and we're going to talk about implicit function, derivative, and how we can use it. So this part, derivatives and differentials, you're going to use it in micro all the time, in macro sometimes, in economic growth all the time, and in econometrics not that much, by the way. Then optimization. If you've never seen what's Lagrangian and what's a Kuhn-Tucker condition, well, you're gonna have to do a lot of work. And again, I know that you're tired of that already, but I really encourage you to take these 2 weeks very serious, because later you won't have time for that. I mean, I understand that maybe now you don't have time for it either because you move in, because you travel, because you have medical insurance phone number, but everybody of PSME went through the same, and everybody after the first year saying, well, I wish I spent more time on math. Okay, then in the end, we're gonna go through matrices and linear algebra. Something that is not difficult at all, but we always forget the rules of how to inverse, how to find determinants, especially when it's 3 by 3. This part will be important, very, very, very important for econometrics. So, more than for anything else. Like in macro, we're not gonna use matrices almost at all. But econometrics will be all about it, especially the beginning, especially the most interesting, well, in my opinion, theoretical exercises where you have to prove something. So for that, we'll do a bit of refreshing of matrices. Then after this, we'll do the test. So the probability and statistics is usually something that we do in the very last class. So on Thursday, next Thursday, we have test. Then on Friday, I give you back your tests. You see the mistakes we discuss, and we cover a little bit of statistics and probability. That, as you understand, is for econometrics. And well, again, you'll do some sort of refreshing during the econometrics class, but well, we're just gonna prepare you for the difficult stuff to come. All right, great, thank you. So now let's go to business. Sum operator. Again, I'll always try to tell you why do we need it for and where exactly in PSME you're gonna face this stuff. Sum operator in economics in general is used in optimization when we have not one consumer but many consumers and we need to sum up their utility functions. So that's the most common example, and that's what you're gonna see for sure during, for example, economic growth. Yeah, economic growth is more about that. Macro will also see a lot of summations at a certain point. So this is not something that I just give you for your general education. This is something that you'll see very, very soon in macro and growth. In micro, not so much. So here we have examples of how sum operator works. So we usually have a variable. In this case, I have I. You have all kinds of notations. It can be k, it can be even n. And then what you have to understand is this I from 0 to n. That's what it means. So the way I read this thing is the sum from 0 to n of this variable. So this is the variable that's gonna change. It will take all values from 0 to n, and that's how we're gonna expand this sum. Given you have a sum of utility functions, it's gonna work the same. Utility for the first consumer plus utility for the second consumer plus utility for the third consumer plus blah blah blah. Utility for all the consumers. Then I have the second example of what can happen within the sum. We can change not just the base, but we can write an expression of exponents. So we're gonna change just the power, which means starting from 0, power of 0, any number in the power of 0 is 1, then a to the power of 1 is a, then a squared, then a cubed, then blah, blah, a to the power of n. And the last example, this is just the simplest things that you already might find boring. but well, good for you if you find them boring. We start here in our third example with 0, because 0 to the power of 2 is 0. Then we raise 1 to the power of 2 square, we get 1. Then we raise 2, we get 4. Then we raise 3 to square, we get 9. And the last one, the last term of this sum, the last element, is n squared. Okay, so now I'm gonna ask you to write me in the conversation part how many terms do we have in this sum? Well, in any of them, because they're all the same. We have from 0 to n. So how many terms? Cool. Okay, great. N plus 1. Thank you very much. I'm happy that this is clear. Seems to be clear. Okay, so what if I put... Yeah, thank you. Great, you all agree. What if I put something like another letter? So let's go to my notebook. Oh, it's kind of big. I chose this because I can really type very fast the expressions that I need. So maybe you're gonna tell me that it's very ugly or something. Don't hesitate to complain. But well, let's hope that it works. Okay, so I put letter A, right? What's gonna change? So what is the sum that I wrote here? Again, use the chat. Well, the previous question that I asked you, how many terms do we have? And you all agreed that we have n plus 1. French keyboard. A. Well, let's write it beautiful. That's gonna be the answer. So since there are n plus 1 terms, we kind of repeat A n plus 1 times. And that's gonna be the answer. So if I use 1, for example, instead of A, and 100 instead of n, well, you know what I'm gonna get. So this is just not that important detail, but important for the understanding of how sums work. So that is gonna be our answer for the sum of A's. Okay, cool. Can a sum go to plus infinity? You can say yes, because yeah, it can. You will actually see this also a lot. Let's go from I equals 0 to plus infinity. Yeah. Okay, cool. It goes to plus infinity, you understand, it's positive. And here we can have something like 1 over n to the power of something. We'll see what this thing is very soon. So let's just write it for now. To the power of I, actually. It's gonna take me some time to get used to this, but I'll manage. Alrighty, so this is something that also can happen to the sum. It can go to plus infinity. I'm gonna just finish with this slide and we're gonna take our break, because as I promised you, it's 1 hour and a half, and I know that you're all tired already. And just so you get in the first presentation, so this is how the sums work. And we have some identities for the sums. So we know that we can factor a constant if we have it in our sum. So for example, if I want to, again here, I'm gonna write this. I have something like my sum from 1 to n, right? And here I have 5a, 5i. So that will be 5 times the sum. Okay. Okay, cool. And then again we have the same sum that just kept there from 0 to n of I. Cool. That's it. So pretty easy. The same thing we're gonna do, like expanding sort of the sum, given we have a sum of two functions, so a sum of a sum, we can split it into two sums. And the limits obviously stay the same. So that's again for your economic growth class.